So now we're going to look at nonlinear equations. Last day we talked about how linear equations have a degree of 1 on your variables in terms of x. Now we're looking at two examples here where we have one that is x squared and one that's the square root over top of x. So they're definitely going to have different properties and things that we need to consider. So we are going to start with the same sort of approach. We're going to try plugging in values for x and see what we get in terms of y. So again, try negatives and positives and see what you get. For this one, let's say we start with, say, -2. If we plug in -2 wherever we see an x, a negative times a negative, so when we square it becomes a positive. So you're going to get 4 plus 4. So then y is going to equal 8. If we continue this through, and let's say we try -1 next. -1 squared becomes 1. 1 plus 4 is then 5. If we plug in 0, we're going to get 4. If we plug in 1, 1 squared becomes 1, 1 plus 4 becomes 5. And if we plug in, say, 2, if you notice, we have a bit of symmetry. -2 gives me 8, +2 gives me 8. -1 gives me 5, 1 gives me 5, 0 gives me 4. So if I plot all these points, and 2 is 8. It's starting to form something that we've already seen before in previous examples. It's actually beginning to form a quadratic. So we have a quadratic function, and it is a function because it is a one-to-one, well, for one input there is one output. But it's not technically a one-to-one function, it's just a function. So that's our first example. For our second example, let's take a look at this. Now there's a couple of things that we need to know, first of all, about square roots. You can never take a square root of a negative number. Okay, you can't take a square root of a negative number. So what's inside of here as a whole can't be negative. But what I plug in for x could be negative. Depends on the type of question. Now in this particular case, we can take a square root of 0. So what would I have to plug in here to get 0? Well, I can plug in 2. Because if I go y is equal to the square root, replace x with 2, 2 minus 2 will give me 0. That I can evaluate. It's going to give me just 0. If I plugged in, say 1 minus 2, that's going to give me a negative value. That will not work. So instead of going smaller than 2, let's go larger. 3 minus 2 becomes 1. The square root of 1 is 1. Now, here's where it gets a little bit trickier, not a whole lot, but if I was to plug in 4 minus 2, well, that gives me then the square root of 2. So, in terms of graphing that, we could estimate approximately what it would look like, but it wouldn't be totally accurate. It's definitely a coordinate pair, but it's just not the easiest one to plot. So, we know that the square root of 1 was 1, and that happened when we plugged in 3. The next perfect square is 4, so the square root of 4. What would I have to plug in so that I get the square root of 4? Well, 6 minus 2 will give me 4. So when x is 6, that's what I've plugged in there, I get the square root of 4. The square root of 4 becomes then just 2. That's a nicer point to use. The next perfect square after 4 would be 9. How do I get 9? Something minus 2 has to equal 9, which would be 11. So 11 minus 2 will give me 9. The square root of 9 then gives me 3. That one's off my grid, but at least I have some points. So I can then start to graph this. At 2, I have a y value of 0. At 3, I have a y value of 1. At 4, I have the square root of 2, approximately 1.4. At 6, I have 2. So 4, I have approximately 1.4, somewhere around there. At 6, I have 2. That's a little bit more accurate. And at 11, way down here, I'd have my 4. It will keep going this general direction, but it will not go anywhere towards 1 or 0 or negative 1, because then I have a square root of a negative value. So this point is actually its starting point. It's a solid dot. This is the positive square root. For all the other types of nonlinear equations, let's just say if I give you y equals to x minus 2 all squared plus 4, or if I give you something in terms of x is equal to y squared plus 5, or even if I give you x squared plus y minus 2 squared equals to 16, let's say. All of these are nonlinear. Their degree is higher than 1. And depending on, if you distribute this one out, you'll see it's degree 2, this one's got a degree 2, that's got a degree 1, degree 2. Again, if I square that out, I'll get degree 2. All of these are definitely not linear. Some of these that we may see may have some restrictions on them. For instance, in this case here, we can't have a denominator equal to 0, because then we're dividing by 0. Since our denominator, or x minus 1, can't equal to 0, as a result, x can't equal to 1. So some of these things are going to have restrictions on them that we have to consider. Just like when we were looking at the square root function, what's inside of a square root can't be negative. So as a result, x has to be greater than or equal to 2. So there are some things to consider. Even this question here, the y squared is quite important. You may want to even consider using the y values to plug in to solve for x. It's just an idea. So take a look at each one of these carefully. With each one, set up your grid and try choosing your numbers that are useful. Keep little things like this in mind where you have restrictions. And if you're working with ever fractions, just think about how you can work with that denominator and eliminate it to find some nice integer values. So, a couple of little things to think about when you're choosing your values to put in your table of values before you start graphing. Some of the questions in the homework will be kind of tricky. Some of them might have asymptotes. Some of them may have starting points. So you need to consider restrictions and think about what values work. Try negative and positive ones and see what happens.